the integral over the surface of a function g of x, y, z with respect to the area of the surface can have any of a number of different interpretations. For example, if g of x, y, z is an area density, that is a mass per unit area, then g of xi star, yj star, f of xi star, yj star is the sample density, and if we multiply that times delta S ij, this is the sample point density times surface area, and the sum of the g of xi star, yj star, f of xi star, yj star, and times delta Sij is approximately equal to the total mass. Okay, now this is sample point density times surface area equals mass of your Ij element. Okay, so this is the total mass, and in the limit this approaches again the integral of g of x, y, z ds over the surface. So in this case our interpretation of the integral would be that the integral gives us the mass of whatever the surface is. Okay, another interpretation, g of x, y, z could be the flux of a vector field f of x, y, z. So the g of x, y, z is flux is f dot n. Specifically then, g of xi star, yj star, f of xi star, yj star times delta S ij would then be the force evaluated at xi star, yj star, f of xi star, yj star. I know this is probably getting a little monotonous, but we want to reinforce this. Dotted with the normal vector. The unit normal. Yeah, let's call this the unit normal. Again, unit normal evaluated at xi star, yj star, f of xi star, yj star, multiplied by the delta S ij. And this sums up so that when we just write this as the sum of the Fij, Nij, delta Sij, where Fij is the force evaluated at the Ij sample point, the normal vector evaluated at the Ij sample point, and the delta S being the surface area at that point, the surface area increment. If we sum that up, that approaches then the integral of f dot n ds. And this gives us a guide as to how to proceed. We're going to set up our surface integral based on a partition of the projection of the surface down into the xy plane. Partition that region of the xy plane, and the sample point, the quantity we get on a sample interval is going to be summed up, limits taken, to get the integral. And the integral in this case, this is a flux, this is the total flux. In the case where the vector field is a gradient of some scalar function, then the integral of g